Alright, here we are back at part 2. So for question number 3, remember there is no quotient rule. We're looking for the area underneath this function from 1 to 9. So before I do anything here, I am going to split my fraction. Split it, because that's a common denominator. I can write this as the area from 1 to 9. This becomes just, if I do the x's, x to the first over x to the 1/2, I get x to the 1/2 minus 4x to the negative 1/2. Don't forget your dx. I haven't integrated yet, so I still need my dx there. And now I can use my power rules. When I integrate this one, we're going to get x to the 3/2, and I flip it, we get 2/3, minus, if this becomes x to the 1/2, and if I flip it, that's going to make that 4 and 8. You can put the plus c here if you want to, but you might remember in part 1, right here, the c's cancel in differentials, in indefinite integrals, so we don't need them there. So I'm going to now evaluate this from 1 to 9. Notice the steps I'm looking for. Did you rewrite it? Check. Did you write your antiderivative? Check. Do you have this? Check. Next, evaluate the integral at 9 minus f of 1. Show this step. Check. Because what we're doing is here, my FTC says to evaluate the area, I look at the difference in the values of the function. We're going to talk about why that is graphically later on. So if I plug in 9, this becomes ugly, times, do this in your head, the square root of 9. See, if I'm doing 9 to the 3/2, I'm just going to take the square root of 9 and cube it. And that's just 27. So I can just multiply this by 27. Now mind you, I have to put the 9 in here too. You got to put the 9 in both of them. It's like distributing it. So minus 8, and that's just the square root of 9, which is 3. Notice I'm not going to simplify. Plug in the 1. We like 1s. You're going to like 1s and 0s in here. 1 just becomes 2/3 minus 8. And there's your answer. Whatever that is. I don't know. I don't simplify. Very easy to do. So let's get triggylicious with it. Time to get tricky with it, right? So secant squared, I know this antiderivative. I'm looking for the area underneath secant squared from 0 to pi over 4. So I know the antiderivative of secant squared is tangent of x. Recall, the derivative of tangent is secant squared of x. And I'm going to evaluate that from 0 to pi over 4. So I'm going to look at the value at pi over 4 minus the value at 0. So, ready? Big parentheses, tangent pi over 4, there's really nothing else to put it into, minus the tangent of 0. Now, you should know tangent pi over 4. If you leave it like this, you will get it wrong. Tangent pi over 4 is 1, minus tangent 0, which is 0, and we get 1. Now, when back in high school, I used to have a little sign I used to carry around. You know, I went to CMR. I would say, CMR is number, and I would have this at 0 pi over 4 secant squared x dx, and everybody knew we were number 1. Woo! All right, be a cheerleader. Now, very easy to do, but sometimes you just want to graph it. So let's take a look at something like this. Anytime we have absolute value, we always graph. So we always graph the following. Absolute value and circles. We're always going to graph those. So here I have absolute value. The first thing I have to find, of course, is the vertex. So this is in a weird form, so I got to factor out the 2. I'm going to get 2, and that's going to give me x minus 1/2. So that's telling me the x-coordinate of the vertex is at 1/2. So when I draw this, we saw this the other day, at 1/2, I want to find it from 0 to 3, and I'm going to draw my absolute value function. If I plug in 0, I can just plug into the function, that's going to give me a height of 1. And if I plug in 3, I get 6 minus 1, which is a height of 5. And instead of evaluating the integral, like using my fundamental theorem, I can just use my triangles. There are two triangles here. So the area would be 1/2. Well, let's look at the first one. The base here is just a half. 1/2 times 1/2 times the height, which is 1, plus the second triangle. Oh no, 3 minus a half, that's just 5/2. That's my base there. 1/2, the base is 5/2, the height is 5. There's your answer. Leave it alone. If you're desperate, that's just 26/4, I think is what it turns out to be. Always graph absolute values and circles. Which brings us to number 6. Tell you, look, here's another absolute value. Here's something you've never graphed before. So remember, the absolute value is basically saying that all y's are positive. That's where my force goes. All y's are positive right here. So when I'm graphing here, I'm just going to pay attention to the inside, which is my parabola. Now I can graph that parabola. It crosses at -3 and 3. I can solve for my x-intercepts pretty easily. And the y-intercept is down here at -9. So I'm going to dash it, just like the hopes of you're passing my class. So I'm going to dash it. Well, the absolute value of the graph says anything that is above the y is positive. We keep. But anything below, we have to flip. So I put my 9 up here, and it flips. Oh my gosh! Do you see it? Do you see it? It is indeed the world famous worn out function. Oh my gosh! I did not mean to draw that, but there it is. The world famous worn out function. Alright, but now what we're asked to do is we're asked to find the area between 0 and 4. So there is no geometric formula. Please don't say that's a circle. That's a parabola. So to get the area, we have to get creative and remember some things about parabolas and flipping them. So I have two areas I have to look at. My first area, and I'm going to split this up, goes from 0 to 3. Plus, I'm going to spread it out, my second area starts at 3 and goes to 4. Notice we take a break at where it equals, at that critical number. So between 0 and 3, this is my parabola, but remember my parabola is flipped, so it's the opposite. So it's going to be negative x squared plus 9 dx. Don't forget your dx. Remember the dx, this is like my area of my rectangle, my Riemann sum, length times width. So we need the dx there. Don't forget your dx. My second rectangle, my second part, is this part of the parabola, which is part of my original. It's an upward facing parabola, so that's just our x squared minus 9 dx. And this I can evaluate. This just becomes, ready, negative x cubed over 3 minus 9x, convince yourself that's true, from 0 to 3, plus, plug in here, x cubed over 3 minus 9x from 3 to 4. Don't cancel anything out. Now notice, once you took the antiderivative, you don't need to put the dx anymore. Plugging in the 3, now we're going to use our FTC, f of 3 minus f of 0, plus f of 4 minus f of 3. It looks nasty, but you know what? We're not simplifying it. We just want to get an answer. Plug in 3, I get negative 27 over 3 minus 3 times 9, which is 27. I don't care what that is. I'm just getting a number. Plug in 0. Oh, that's just 0 minus 0. Plug in 4. 4 cubed is 64 over 3 minus, plug in 4 to the 9, 36. Plug in 3. 27 over 3 minus 27. I don't care what this equals. I just want to get a number. Alright. And seriously, I messed that up. That should be a minus, makes that a plus. Which makes that a plus. Sorry about that. I copied it down. I distributed early, so that should be a minus. The answer is right, but I did my work wrong. Please forgive me on that one. Alright. There is one more that we always do. Circles. If I'm asking you to find the area from 0 to 3, you're going to see this on the test of 9 minus x squared dx, where this is a circle. radius 3. Just draw it. I'm only interested from 0 to 3. So if I want to find that area, this is a quarter of a circle, pi times 3 squared, or 9 over 4 pi. Right there. And there we have it. Alright. Hope you guys enjoyed the video. I'm not going to do this one with you guys. I guess we can try this one. I'm just going to set this one up. Just set it up. If I want to find the area bounded between this graph and the x-axis, between 0 and 2, that's just looking at our integral. That's what integrals find, from 0 to 2, 2x squared minus 3x plus 2 dx. You can solve that. I guess we can solve it. Why not? This becomes 2/3 x cubed minus 3/2 x squared plus 2x. And evaluate that from 0 to 2. We would get f of 2 minus f of 0, and plugging this in, we're going to get, don't worry about simplifying, 2/3, 2 cubed is 8, minus 3/2, 2 squared is 4, plus 4, 2 times 2, and all that's just becomes 0. You're going to like zeros in here, and there's your area. I hope you guys enjoyed the videos. I do apologize for my error up there. I was trying to distribute earlier, but the original was a -9. I put a +9, I distributed, but now when I distribute, the answer here should be a plus, which makes that a plus. I do apologize for that. Other than that, I think we did a good job together today. I'll see you all later. Bye-bye.